In this video, we're going to solve differential equations using separation of variables. So if you want to solve this differential equation, notice the x and y are all together. So what we need to do is we need to separate. So for example, we need to put all the y's on one side, all the x on the other side. And also, remember, dy over dx, they have to be a numerator when you solve differential equation. So dy is already a numerator. We need to make dx into a numerator. In order to do that, we have to move dx to the other side by cross multiplying. So when you cross multiply, you end up getting this. Quantity 2y plus cosine y dy is 6x squared dx. Now all the y's are on one side and all the x's are on the other side. And dy and dx are numerators. Now we're going to take the integral of both sides. So you end up getting y squared plus sine y plus c1 equals, you end up getting 2x cubed plus c2. So you get y squared plus sine y equals 2x cubed plus c, where c is c2 minus c1 under the constant. Now this is a general solution because we don't know what c is unless they give us more information. Let's say the solution of this equation, which is this, satisfy y of 1 is pi. Let's say they gave us this information ahead of time. So when x equals 1, the y value will be pi. If they had given us that information, all we got to do is plug it in. So what is y when x equals 1? Pi. So it's going to be pi squared plus sine of pi. I'm sorry, yes, pi equals, now x is 1. Now we could find what the value of c is. So it's going to be pi squared. What's sine of pi? That's 0. And that becomes 2. So our c is going to be pi squared minus 2. So a particular solution, given this information, will be y squared plus sine y equals 2x cubed plus pi squared minus 2. Now you got y prime equals x squared y, and we need to solve this differential equation. So let's rewrite y prime as dy over dx. And we need to separate the variables. So you get dy over y is x squared dx. And we need to find the integral of both sides. So what's the energy root of this? That's natural log of absolute value of y. And it becomes x cubed over 3 plus c1. Now how do you get rid of natural log? You have to do e. You have to change the base as e. So e and natural log cancels out. You get absolute value of y is e to the x to the third over 3 plus c1. That this becomes exponent. So now remember, e to the a times e to the b is e to the a plus b. So we're going backwards. So we could say this is absolute value of y is e to the c1 times e to the x to the third over 3. Now remember, this is another constant, okay? But before we change that, since this is absolute value, you get y equals positive negative e to the c1 times e to the x to the third over 3. Remember, this is another some arbitrary constant. So we could call it A or C depending on what your preference is. So the final answer is going to be y equals C e to the x to the third over 3. So that will be our final answer. Okay, we have a general solution here because they didn't give us more information to find what the value of C would be. In this example, we need to solve this differential equation given that y equals 1 and x equals 1. In other words, when x equals 1, the value of y will be 1. So in order to simplify this, we get dy over dx equals x squared y squared. We got to separate the variables. So you get dy over y squared is x squared dx, which is the same thing as y to the negative 2 dy equals x squared dx. And we got to find the integral of both sides. So we end up getting negative y to the negative 1 equals x cubed over 3 plus c. Let's call it c1. So this is the same thing as if you want to solve for y. Actually, let's solve for c1 right now. Because when y is 1, I'm gonna change it to negative 1 over y is x cubed over 3 plus c1. Now let's just solve for c1 here. So let's plug it in. You get negative 1 is 1/3 plus c1. So move 1/3 to the other side, you get negative 4 over 3 is c1. So now this is the same thing as negative 1 over y is x cubed over 3 minus 4 over 3. Now we have to solve for y. So it's all algebra 1 now. Algebra 2. I don't like that negative, so I'm going to multiply both sides by negative. So you end up getting, instead of that, you get 4 minus x cubed over 3. I multiply both sides by negative. And then 1 over y, I'm going to flip it over. So y over 1. Since I flip over this side, I have to flip over the other side to make it equal. So this will be your solution of this differential equation when y equals 1 and x equals 1.